All of you welcome in our first period MSc Sem 2 Mathematics paper 4 Classical Mechanics. First we see Unit 1 Variational Principle and Lagrange's equations. First we see the definition of monogenic system. Monogenic system. Hamilton's principle describes the motion of those mechanical systems Hamilton's principle describes the motion of those mechanical systems the motion of those mechanical system for which all forces are derivable for which all forces are derivable from a generalized scalar potential. Generalized scalar potential. That may be a function of coordinates, that may be a function of coordinates, velocities and time. Such systems are called monogenic system. Are called monogenic system. Now we see next Hamilton's principle for monogenic systems. Hamilton's principle for monogenic system. The motion of a system from time t1 to t2. The motion of the system from time t1 to t2 is such that the line integral given by I equal to integration L dt, where L is the Lagrangian, integration from time t1 to time t2, where L is, you know that L is the Lagrangian, where L equal to T minus V, kinetic energy minus potential energy, which is the Lagrangian, has this integral has a stationary value for the actual path of motion. For the actual path of motion. That is, the principle is this line integral L dt from t1 to t2 has a stationary value for the actual path of motion. Stationary value means maximum or minimum value. The line integral one is called action, or it is called an action integral. The line integral one is called action or action integral, where this L is the Lagrangian, which is the function of q1, q2, so on, qn, q1 dot, q2 dot, qn dot, and so on, also with time. So according to the Hamilton's principle, the motion of a system is such that the variation of the integral I from time to t2, from time t1 to t2 is 0. Variation of this means delta. Delta of this integration is 0 from time t1 to t2. According to Hamilton's principle, the motion is such that the motion of the system is such that the line integral the variation means delta, variation of the line integral I equal to integration t1 to t2 L dt for fixed t1 and t2 is 0. That is, we are written as variation of this integration means delta, that is delta I equal to delta of the integration delta t1 to t2 L dt is 0, where L is the function of q1, q2, so on, qn, q1 dot, q2 dot, so on, qn dot, and also with time t, where the system is holonomic, where the system constants are holonomic. Constant means the parameter to define the motion.